Okay, so today we're going to start off by talking about soft bottom intertidal communities. And we'll talk a little bit about the characteristics of a soft bottom intertidal community, how they're different from a rocky shore community. And then we're going to get into the different soft bottom intertidal communities. So let's see. The first thing we're going to talk about is what makes a soft bottom intertidal community a little bit different than your rocky shore intertidal community. And so any bottom composed of sediment as opposed to rock is going to be considered your soft bottom intertidal community. So soft bottom communities are going to have more infauna, right? Because epifauna are things that attach to the top of something like a rock. So in your soft bottom communities, you are going to have things that can't attach to the top of the sediment because it's not stable. So you're going to have things that are going to be more infauna, organisms that can burrow in easily. So our dominant sessile organisms here, dominant non-motile organisms here are going to be infauna. And when we talk about soft bottom intertidal communities, remember that you're going to mostly see them on the East Coast, especially south of Cape Cod, where we have a passive margin. Remember, on the West Coast, we have more active margin, and that's going to leave us with steeper shorelines and more rocky shorelines. And so really, we find soft bottom intertidal communities mostly on the East Coast, south of Cape Cod, and then virtually all of the Gulf Coast. So in our soft bottom intertidal communities, again, these are going to be more unstable, just like we talked to, because organisms don't have a place for permanent attachment. So we're going to see things like sea grasses instead of seaweeds. Remember seaweeds? And we're going to get into this in a little bit when we talk about kelp forests and we talk about algae a little more. But seaweeds they have a holdfast and they need to attach to the top of something. So we're not going to find many seaweeds in a soft bottom intertidal community because there's nothing for that holdfast to attach to, nothing stable. So we're going to see things like sea grasses. And we're going to talk about how sea grasses and cord grasses and things like this are able to form these things called rhizomes, these horizontal roots to help anchor them in that unstable soft sediment. So we're going to talk a little bit about that. And then we'll also talk about the fact that, again, we have mostly infauna here. This is a huge thing, right? You know, you're going to see this somewhere on the test, that you have mostly infauna in your soft bottom intertidal communities and mostly epifauna in your rocky shore communities. So again, you're going to have, here's some of the sea grasses here, and then you can see here's all of the types of, not all, but many of the types of infauna that you're going to see. Again, you're going to see clams, you're going to see burrowing polychaete worms, you're going to see polychaete tube worms. So again, things that are going to burrow into the soft bottom. And so remember that the most important abiotic or physical factor that affected rocky shore communities was space, right? Just the amount of space because they needed something to attach to. Well, here in the soft bottom intertidal community, that's not really an issue, right? Because things are burrowing into the sediment. So the most important physical factor here is going to be the size of the sediment granules. The size of the sediment granules will be different in your different soft bottom intertidal communities. We're going to talk about this. And that is going to determine what types of organisms you're going to have in that environment and the biodiversity of that environment as well. So let's look at this. So when we talk about our soft bottom intertidal communities and the sediment sizes, we can go anywhere from things like gravel, okay, which are pretty large, about, you're talking about 2 millimeter size grain pieces, down to like silt and clay, which we're talking just a tiny fraction of a millimeter. So this is going to be your silt and your clay are going to make up your mud. And then your sandy beaches are going to be a mix of more sand and gravel. So the sediment composition is going to be directly related with the water movement through what's called these interstitial spaces. Interstitial, I'll show you this term in just a minute. Interstitial space just means the space between the sediment granules. And fine sediments are going to be typically found, so your silt and your clay are going to be found in calmer areas that are partially protected and enclosed, like bays and lagoons, where they're protected from the wave action. And then coarser sediments are going to be found in areas where you are subject to more heavy wave action. So living in the sediments, soft bottoms, again, are going to hold more water. So desiccation isn't as much of an issue for these guys when the tide's out. Still somewhat of an issue, but not as big as the rocky shore communities where you're exposed. Coarse sands are going to drain and dry out a little more quickly. So honestly, there's less animal life in a sandy beach community than there is in an estuarine muddy community, like your estuarine mud flats. So sandy beaches are kind of, in terms of animal life, really not very biodiverse. And as a biologist, not that exciting. So I would prefer to go to an estuary that with a sticky, stinky mud any day over a walk on the sandy beach. I know, my poor husband, right? But those in terms of biodiversity, your coarse sands just don't provide a whole lot of animal life, and that's because they dry out quickly. They drain quickly and they dry out quickly because they have those larger interstitial spaces. There's few primary producers. So because of that, detritus is the main source of food, and you're going to have mostly deposit feeders living in your sediment communities, your soft sediment communities. So this again is a big difference from your rocky shore communities where you didn't have very many deposit feeders because there weren't deposits to feed on, right? So that's the opposite here. Coarse sand also is going to have less detritus because again, that water is going to kind of wash it through. So then again, that's another reason why your sandy beaches are going to be less diverse than your estuarine muddy communities. So silt and clay is going to be much more rich in detritus. So why is there more detritus in muddy sediment communities, more so than coarse sand? And it's partially just because particles of organic matter are going to sink at the same rate as clay particles. So dead and decaying matter is going to sink at the same rate as your fine clay particles. And clay sediments then are just going to be more organic rich because they settle at the same time. So detritus is, again, going to be really important because for your soft bottom communities, because again, you have mostly detritus feeders. And so this is just a quick little video clip. Maybe I won't be able to play that one for you. I was hoping I'd be able to play this one for you. Let's try that again. Let's see. And this was just a short little video clip. Maybe it's not going to work for me here. Let's try this. No. Well, I'll post this separate for you, but it just talks a little bit about why, sediments, again, in these partially enclosed bays, sediments are going to be mostly rich in clay particles. And it's simply just because, again, you don't have as much wave action, and that'll actually allow those fine particles that stay kind of suspended in the water in areas where there's more heavy wave action. In these protected areas, like your bays and your lagoons and your estuarine communities, it's going to allow them to settle, the clay and the silt to settle on the bottom before, again, it's rushed out with the tides. So that's why you're going to see this in your, you're going to see these. I'm going to try one more time. I just don't think it's going to do it. So I'll post this video for you. Sorry about that. It's just a really short video clip, but it just is a nice, nice kind of depiction, visual depiction of why, again, these estuarine communities form in these areas. And mainly, again, it's because in your estuarine communities, you're going to have freshwater and saltwater meeting. Okay, but we're going to get to estuaries in just a minute. We're going to kind of really briefly kind of more just introduce, this is just soft bottom, intertidal communities in general. We'll talk really quick about sandy beach communities, and then we're going to really get into the heart of estuary communities. I have a whole lecture on them because they're just so diverse and amazing. So again, living in the sediment, less oxygen is going to be available. So you don't have a lot of primary producers. So really, you're mostly going to have bacteria that are, and when you talk about your primary producers, there are a few primary producers. You'll have things like seagrasses and salt marsh plants. We'll talk about mangroves. But for the most part, you're going to have a lot of bacteria, and you'll even have photosynthetic bacteria called cyanobacteria. And so in the sediments, because you don't have a lot of primary producers in the sediments producing oxygen, and then you have bacteria and animals using up oxygen within the sediments, you end up with very little oxygen, especially when the tide goes out, okay? So there's less oxygen available. So in-fauna really depends on the circulation of water through those sediments to kind of replenish their oxygen supply with the incoming tides. Now, you can see here, this shows you the water movement through the interstitial spaces. So here, again, these are called interstitial spaces. And if I could write that for you, I'm just going to write down. I don't know if I have this in here for you, and I don't have my easy way to write. So excuse my handwriting here, but this is called interstitial, that's an S if you can't tell. Interstitial spaces. So interstitial spaces. I believe I have this somewhere in the lecture for you, but just in case. So interstitial spaces there. And that's, again, just simply the space in between the sediment granules here. So you can see that water, if you have, again, what we call well-sorted coarse sediment, that means you have larger grain sizes. You're talking about, sand and gravel here, and they're about all the same size. Then you're going to have these large interstitial spaces, and the water is going to drain very quickly through here. So again, this is going to dry out really quickly when the tide's out. Well sorted means that you have fine particles. So you have small particle sizes. So you're talking about your clay, and even, well, probably more your silt, honestly, here. So a little bit bigger. And so, but they're all about the same size. And so your water is going to drain slowly, but it will still drain. Now, in poorly sorted, which is you're going to see in a lot of your estuarian kind of muddy communities where you have a mix of silt and clay, and even some, some larger sand grain size pieces here. In those types of communities, what's going to happen is those interstitial spaces are going to be really small, and water's not going to move well through them because they're poorly sorted. So what interstitial spaces you had here are filled with fine clay particles. And that means that the water is basically going to be blocked, and the mud will become waterlogged here. And we'll talk about this in terms of this environment down here below this line becomes anoxic because fresh water isn't coming in to replenish the oxygen. So we'll talk about that. So living in the sediment, muddy bottoms are going to have, again, more organic material to use up oxygen, and the flow of water to, again, as new water is brought in with the tides, it's only going to move down so far in those muddy bottoms because they're poorly sorted. And so we're going to have this anoxic soil just usually a few centimeters below the surface. So this anoxic soil is going to be stinky, and if you've ever been in an estuarine community, it kind of smells a little bit like rotten eggs. And the reason is because even though it's without oxygen, of course, okay, there is one organism that can inhabit, right, these completely extreme environments like an anoxic environment with no oxygen, and that is, of course, bacteria. Bacteria, right, are just everywhere. They find a way, right? So we've got anaerobic bacteria just a few centimeters down in muddy soil that are actually producing hydrogen sulfide, and that ends up turning the sediment black. So you can see here, just a few centimeters below the surface in your estuarine communities, you're going to have this really sticky, black, muddy, sediment. And the reason that is of course these hydrogen sulfide producing bacteria. These bacteria that are what we call anaerobic. They don't need oxygen. So anaerobic bacteria, and they produce this hydrogen sulfide as a byproduct of their respiration. So meaning their metabolic processes that they do without oxygen. So that's why estuaries kind of seem like they're this, really stinky, kind of gross area, but they're actually not, because this bacteria is then going to provide food for some of your detritus feeders. So our estuarine communities are actually really, really quite diverse. So how have infauna adapted to the short supply of oxygen? So many of them, like your bivalves, are just going to siphon water from the top. They're going to pump oxygen-rich water from the top, especially when, again, the tides are in. So again, your clams are going to have these, and many of them have really long siphons, like as we'll talk about in our estuarian communities. Some even have special hemoglobins, special proteins that attract more oxygen for them when they're out of the water. So that way then they really hold on to more oxygen with those special hemoglobins. And then some of them simply are just very sluggish. And so in a lot of your soft bottom communities, many of your organisms are going to be slow moving. They have slow metabolisms so that they can use less oxygen, and they're just going to be kind of slow moving. So, and then I have here, don't forget about myofauna. Now, we didn't do the myofauna lab, which is a bummer. So I'm going to try to show you a video. But myofauna is this stuff that's going to live in the interstitial spaces of sediment. So this is going to be kind of the microscopic stuff that you're going to see in between the sediment granules. And they're just really really cool. I don't know if any of you recognize this guy here, but this guy right here is called a water bear, a tardigrade or water bear. And they are really pretty amazing organisms. And so your myofauna is going to be all of this stuff that literally lives and moves in between these interstitial spaces, these spaces between the sediment. And it's of course not gonna, I'm gonna try this a different way because I'm not sure why these are not working in my, but this one's a really good one. And I'm gonna try this, for some reason it is not wanting to work in Safari. So I'm gonna just try a slightly, oops, excuse my game and fish there. I'm gonna try a slightly different method here to get you through this. Because this one is a good. So again, this is myofauna, life in between the sediment in the interstitial spaces.
More than 70% of the Earth's surface is covered by the oceans. About 90% of the ocean floor is made of sediments, which include grains of mud, sand, and gravel, which are constantly moved by the action of currents, tides, and waves. This apparently uninhabited environment, however, reveals an enormous diversity of life forms. A careful watcher may easily notice many species of animals, like crabs, hermit crabs, clams, and marine worms. But these relatively large animals are not alone in this place. In the tiny space between the sediment grains, there is a much more abundant and diverse fauna, invisible to the naked eye. They are small organisms, smaller than 1 millimeter, termed as myofauna.
I'm so sorry, this might
Dos
ruin
aspectos interessantes do estudo da
your sandy
meiofauna é
beaches
que
for
dos
you.
cerca de 35 a 40 filos animais descritos, cerca de 25 deles ocorrem nesse ambiente. Alguns passam seu ciclo de vida todo entre os grãos de areia ou
So
sobre
this
os
is a
grãos de areia,
peanut worm.
enquanto outros passam uma parte da vida na meiofauna
Again, a
e
tiny
quando adultos
Nigerian.
vão fazer parte da macrofauna.
Para obter organismos meiofaunais, basta uma pequena quantidade de areia ou lama. Por exemplo, neste pequeno volume, podemos encontrar dezenas de espécies e milhares de organismos.
Once collected, the sediment is sieved through different mesh sizes, permitting the classification of the fauna into macrofauna and myofauna. Specifically for the myofauna, the material retained on the smaller mesh size is then observed under a stereo microscope. The organisms are picked up with micropipettes and transferred onto glass slides for examination at higher magnification. The observation of live material under the microscope allows us to see many of the essential morphological adaptations needed to inhabit and survive in this environment, an environment paradoxically large with many tiny interstitial spaces. For instance, in habitats subjected to strong water currents, where gravel, shell, and coral fragments prevail, some organisms attach to the grains. This life strategy allows them to capture suspended particles or prey upon other small animals without being dislodged by the water movement. Other species are modal and, when necessary, attach to the grains by means of adhesive structures, such as caudal glands. Adhesive toes, and tactile setae. Others attach themselves by means of hooks. Or by muscular action and secretion of mucus. Armature to reinforce and protect the body from abrasion due to sediment agitation is another essential adaptation necessary to live in this dynamic environment. In habitats exposed to wave action, many organisms of different phyla have evolved a vermiform shape. Or are extremely agile.
So vermiform just means worm-like. So there's your
These adaptations allow them to move deeper into the sediment layers as a protection against the wave action. Another adaptation to live in this environment is the flattening of the body and the presence of ciliary bands for locomotion. These morphological adaptations permit the exploration of the labyrinth of the interstitial system and the surface of each grain of sand.
So you guys can go ahead, you can watch the rest of that. I just wanted to introduce you to what myofauna is and what it looks like. And so again, if you had, if I had you in a normal, your 15-week semester, we would actually do a myofauna lab. And you would actually get to see some of this myofauna. You would get to see some gastrotrichs, some rotifers and water bears, some nematodes, roundworms. But anyway, The important thing is that you know that there are these microscopic organisms that are living in the interstitial spaces in the soft bottoms. And here's actually some photosynthetic ones. These are called diatoms. They're a type of algae, microscopic algae, and they're actually a primary producers in these soft bottom communities. So you'll never look at a sandy beach the same after seeing this, because there's there's all of this life living in between those interstitial spaces. And so what, again, of course, are most organisms feeding on? So they're feeding on detritus within the interstitial spaces. Other organisms are actually feeding on the myofauna. So when you talk about what are organisms feeding on in these soft bottom communities when they're eating, they look like they're eating the mud. They're actually eating the organic decaying material detritus, but also they're eating real organisms, animals that are living in the interstitial spaces. And that's all your myofauna. And as you saw, there's quite a bit of myofauna, especially when you talk about things like your estuarine communities. There's a lot of myofauna. And then you even have diatoms, again, that are photosynthetic algae, microscopic algae, and then plankton's also brought in by the tides. So again, there's quite a bit for organisms to feed on in these soft bottom communities. So hopefully you enjoyed that on the myofauna, even though we didn't get to do the lab here. And then, so really briefly, we are not going to talk about sandy beach communities much at all, because again, they are just not really very biodiverse in terms of your soft bottom communities. And so this is just kind of a quick rundown of your very basic food web for a sandy beach community. So again, at the basis of it, you have detritus and some myofauna organisms are living in there. So you've got deposit feeders like polychaetes, clams. You'll have, again, the microscopic myofauna, that a lot of those are deposit feeders. You've got suspension feeders in there. So again, clams are going to be a big suspension feeder. Crabs, sand crabs, will also suspension feed. You can see this one positioned itself that way. Sometimes some of your polychaete worms, like you're going to see in the video that you're going to watch for lab, there are some of your polychaete worms that form tubes and are called tube worms. And they'll have these feathery feeding appendages to do suspension feeding. So you'll see that in some of like your feather duster worms. And then, but the big thing here is that you're going to have carnivores that are coming not only from the intertidal communities, so things like predatory moon snails and sometimes even fish when the tide's in, but you're also going to have birds, wading shore birds, from some of your more terrestrial communities. So again, that's kind of a change for some of your soft bottom communities. So again, we're just not going to talk a whole lot about your sandy beach communities, because those interstitial spaces, they're well sorted and larger, and so water is going to drain more quickly. There's going to be less myofauna in your sandy beach community than there is in your estuarine communities. So it's just going to support a little bit less in terms of biodiversity and overall animal life. Okay, so I'm going to go ahead and end this one here, and then I'll start up the next one with your estuarine communities.